Welcome back to AI.Code.Cast, where we help you level up your coding skills by tackling some really interesting problems.
Yeah.
And today we're diving deep into a classic problem. You've got a limited number of meeting rooms, a
Right?
whole bunch of meetings with different start and end times,
hmm
and you need to figure out which room is the busiest one.
Exactly. It's a problem that comes up a lot more than you think.
It really does. I
Mhm.
mean, it's not just about physical meeting rooms, right? This applies to all sorts of resource allocation
Oh,
problems.
absolutely.
So
Imagine you're managing servers and you've got tasks coming in. Each task needs processing time, just like meetings need a room.
that's a great analogy.
hmm
So, okay, let's make this concrete.
Hmm.
Imagine we have 3 meeting rooms and a whole list of meetings.
Right.
Some overlap, some don't.
Right, it's like a scheduling puzzle.
Exactly. What's the first approach that comes to mind?
Well, I guess the most straightforward way would be to go through each meeting one by one
Okay.
and try to fit it into the first available room.
Right. If room's free, great.
hmm
If not, move on to the next meeting.
Yeah, or try to find a later slot.
So that's basically the brute force method in programming, right?
You got it. Just try everything until something works.
But we both know that brute force isn't always the most elegant or efficient solution.
Especially when you have a ton of meetings and rooms to deal with.
It's like searching for a book in a library by checking every single shelf.
Uh,
You'll find it eventually, but it'll take forever.
yeah, exactly. It's not very smart.
So what's a smarter way to approach this? How can we be more targeted in our approach?
Well, instead of randomly assigning meetings, what if we had a way to prioritize them based on some criteria?
Okay, I like that. What kind of criteria are we talking about?
Well, think about the goal. We want to find the most used room, right?
Mm,
So whenever a room becomes free, we should try to give it to the meeting that needs it the most at that moment.
that makes sense. But how do we decide which meeting needs it the most?
Well, we could look at the start times of all the meetings that are still waiting. The meeting that's supposed to start the soonest is probably the one that's most desperate for a room at that point.
That's clever. So we need some way to keep track of which meetings are waiting
Yes,
and then sort them by their start time so the most urgent one is always at the top.
precisely. It's like a VIP line at a club.
Haha.
Yeah.
Where the most important people get to go first. Except in this case, the VIPs are the meetings that need to start ASP.
Exactly. And in programming, this kind of VIP line is called a priority queue.
Ah, priority queues. Now we're talking.
Yeah.
I've heard of them, but to be honest, I've never really used them. How would they help us in this scenario?
Okay, so we actually need two priority queues.
2. Okay.
One for the rooms that are available
Ah.
and one for the rooms that are currently busy.
Okay, 2 queues. I'm intrigued. Tell me more.
So the available rooms queue is like a neatly organized stack of empty rooms,
Got it.
all ready to be used, and it's sorted so that the lowest numbered room is always at the top.
So if room number 1 is free, it's at the front of the line, followed by room 2, room 3, and so on.
Exactly. It's like having a receptionist who always knows which room to offer first.
Makes sense. And what about the busy rooms queue? How does that work?
So that one keeps track of all the rooms that are currently occupied, along with information about when they'll be free again.
Okay, so it's like a list of checked out rooms with their expected return times.
Exactly. And this queue is sorted by the end time of the meetings, with the room that's going to be free the soonest always at the top.
And if 2 rooms become free at the same time?
Then we prioritize the one with the lower room number.
Got it. So we've got these 2 queues, one for available rooms and one for busy rooms. Each one neatly sorted based on our criteria. But how do we actually use them to solve the problem?
Okay, so that's where things get really interesting. We start by taking each meeting in chronological order and fins. We check our busy rooms queue first
Okay.
to see if any rooms have become free since we last checked.
Right, because meetings are always ending.
Exactly. So we compare those end times from the busy rooms queue with the start time of the meeting we're currently looking at.
Okay, so if we find a room in that busy rooms queue whose end time is earlier than or equal to the start time of our current meeting,
Yep.
then we know that room's free now.
Precisely. We take it out of that busy rooms queue
Uh-huh.
and we put it back into the available rooms queue.
Right. Always making sure it stays nice and sorted.
Exactly. So now we're at a crossroads. We ask ourselves, do we have room available or are we all booked up?
Right. If there's an available room, I'm guessing it's pretty straightforward.
Yeah, it is.
We grab that room from the top of the available rooms queue,
Right.
assign it to our current meeting,
Yep.
and then we add that room and the meeting's end time to the busy rooms queue.
You got it. But what if every room is taken? That's where it gets a little more interesting.
Okay, I'm all ears.
Yeah.
What happens when there's no room at the end?
Well, in that case, we take a peek at the top of the busy rooms queue
Okay.
to see which room is going to open up first.
Right, because that queue is sorted by the meeting end times.
Exactly. So the top one's the one we care about. But we can't just assign the meeting to that room right away.
Because what if the meeting starts before the room's actually available?
That's a great point. We got to be mindful of potential delays.
Right. So how do we handle that?
Well, we figure out the difference between the meeting's start time and when that room's going to be free.
Okay, so that difference is our delay.
Exactly. Let's say a meeting's supposed to kick off at 10 a.m., but the only room we've got won't be open till 10:15.
Uh-huh.
That's a 15-minute delay.
Got it. So what do we do with that delay time?
We add that delay to the meeting's total time.
Okay.
And that updated time becomes the new free time for that room in the busy rooms queue.
So it's like we're pushing back that room's availability to factor in both the delay and how long the new meeting will last.
Exactly. And of course, we bump up that room's count to show it's hosting another meeting.
Right. And we just keep repeating this whole process.
Yeah.
For each meeting on our list, checking if rooms have become available, figuring out any delays, and updating those two queues as we go.
It's like a constantly moving dance between availability, delays, and those super organized queues.
I love that. And in the end, we just look at the counts for each room.
Yep. The one with the highest count is our superstar, the most popular meeting room.
This whole process feels so much smoother than just randomly trying to fit meetings in wherever they fit.
Right. It's all about having that clear strategy, using those cues to really streamline things.
I'm really starting to see how useful priority queues can be for this kind of optimization.
They're super handy. Anytime you've got limited resources and you need to make choices based on certain factors.
Like our meeting rooms and start times.
Exactly. Okay, so I'm sold on priority queues. I get that they're awesome, but honestly, they still feel a little intimidating to actually code up. Any advice for our listeners who might be feeling the same way?
Yeah, definitely. Don't get overwhelmed.
Yeah.
Just take it one step at a time.
Let's think through the logic. Like we're talking to a friend who codes, you know? No need to get lost in the nitty-gritty details of the actual code just yet.
Perfect.
Yeah.
So let's chat about the pseudocode for this solution.
Sounds good. So first things first, we got to think about how we're going to represent our meetings.
Okay?
We could go with something simple, like a list or an array.
Uh-huh.
Each item in that list would be a meeting containing its start time,
Right.
end time, and maybe a unique ID if we need to tell apart meetings that happen to have the same start and end times.
So it's like each meeting is its own little package of information tucked away neatly in our list.
Exactly. Now let's get those priority queues set up. For the available rooms queue, we started off with all the room numbers we have,
Okay.
sorted in order from smallest to largest. That way, if we have multiple rooms free at the same time,
Uh-huh.
we always go with the lowest numbered room first.
It's like we've got that stack of rooms I mentioned before with room number 1 right at the top, ready to go.
Exactly. Now, the busy rooms queue starts off empty because at the very beginning, none of the rooms are in use.
Makes sense.
Mm-hmm.
So we've got our meetings all organized, our queues are ready to roll. What's next? How do we actually use them to make those room assignments?
Okay, so picture this. We're at the first meeting on our sorted list. What's the very first thing we should do?
Well, we got to see if any rooms have freed up since the last meeting, right?
Exactly. We check those end times in the busy rooms queue against the start time of the meeting we're on now.
So if we find a room where the end time is the same or earlier than our current meeting start time,
Uh-huh.
that means it's open.
Bingo. We pop that room off the busy rooms queue
Okay.
and add it back to the available rooms queue, keeping it sorted nicely by room number, of course.
It's like they're checking back in after their last meeting, ready for a new one.
I like that. Okay, decision time again. Is there an available room in that available rooms queue, or are we still booked solid?
So if there is a room free,
Yeah.
we just take that top room from the available rooms queue, assign it to our current meeting,
Right.
and then add that room with the meeting's end time to the busy rooms queue.
Perfect. But what if all the rooms are still taken? That's where our delay logic comes in.
Right. If there are no rooms in the available rooms queue,
Yeah.
then we take a look at the busy rooms queue,
Uh-huh.
and we see which room is going to free up the soonest.
Exactly. But we got to be careful. We can't just assign the meeting to that room right away, like we said before.
Right. We have to factor in that potential delay.
Exactly. We take the room's availability time
Okay.
and subtract it from the meeting's start time.
So if that difference is positive,
Yep.
that's our delay.
Right on. Let's say the meeting's supposed to start at 1 p.m., but that soonest available room isn't free until 1:30.
Oh.
We've got ourselves a 30-minute delay.
And then we add that delay to how long the meeting's supposed to last.
Exactly. So if that meeting was originally scheduled for an hour, it's now going to end at 2:30 p.m. instead of 2 p.m. And that 2:30 becomes the new availability time for that room in the busy rooms queue.
Right, so it's like we're shifting that room's availability to make room for both the delay and the actual meeting time.
Precisely. And we bump up that room's count because it's hosting another meeting.
Got it. And then we just keep going through all the meetings.
Yep. Checking for any newly free rooms, calculating those delays if we need to, and making sure our priority queues stay up to date.
This is way more efficient than just trying to cram meetings in wherever they fit.
Oh, absolutely. It's all about that strategy, and those priority queues make it so much smoother.
Priority queues are a lifesaver for this kind of problem.
Mhm.
I'm definitely going to have to start using them more.
They're great. Anytime you're dealing with these resource allocation challenges where things need to be prioritized.
Right, like our meetings and their start times.
Exactly. So yeah, for all our listeners out there, don't be afraid to get your hands dirty with different data structures and algorithms.
They can really make a difference.
Absolutely. And when you run into a tricky problem, break it down. Take it step by step. Think through the logic. And you'll be amazed at how elegant and efficient your solutions can be.
That's a great note to end on. Thanks for joining us on AI.Code.Cast for this deep dive into priority queues and meeting room allocation. I hope you learned a thing or two about how to tackle tricky coding problems with the right tools and a little bit of clever thinking.
Happy coding, everyone.